let's start. First of all, thanks for being here, attending this webinar. I would say good evening, good afternoon, or good morning, wherever you are in the world. And today we are here because I'm going to present you some outcomes of fluvial flood hazard assessment studies in urban areas that we have developed in the past month of years, exploiting the capabilities of advanced hydraulic numerical modeling. Nowadays, we are living in an era characterized by a fast urbanization, where more and more people are moving to urban centers for different kind of motivational purposes, for job, for changing life, and whatever. But even if located far from water bodies, this doesn't mean that the risk of being affected by flood is reduced to zero. And indeed, we are constantly bombarded by news from every corner of the world, where our cities are strongly affected by the harsh impact of climate extreme. And here, some screenshot just taken from the end of last year, the beginning of this year, of really a huge number of cities affected by hydrometeorological extremes. I will start presenting first studies that we developed during a research project in Italy, where in order to investigate the impact of these really meteorological extremes on the UNESCO Cultural Heritage City of Florence, the University of Florence started with a project called Talete, that had the aim of protecting the cultural heritage preserved in the district of Santa Croce. And as you know, as probably you know, the historical city center of Florence, and especially the Santa Croce district, contains two of the most important cultural heritage sites in Italy, meaning the Santa Croce Cathedral and the National Central Library of Florence. That is one of the biggest national central library in Europe. But looking at the geographical location of this area, we can immediately spot that it is dangerously exposed to a multiple source of hazard. First of all, we have the river flooding due to the proximity to the Arno River. Indeed, this area was strongly affected by the catastrophic flood that occurred in 1966. And secondly, less obvious, is the hazard that lies beneath the surface, namely the overflowing by the sewer network. Indeed, the internal drainage network of the analyzed complex is directly connected to the urban and public sewer system. In order to study all these phenomena and investigate the hazard related to extreme rainfall, we exploit the potential of InfoWorks ECM, and we developed a doc 1D2D dual drainage model to basically investigate to provide a comprehensive evaluation of the interaction between let's say, I will list first the internal drainage network, so the network of pipes draining the two buildings that I mentioned before, so the National Central Library and the Monumental Complex of Santa Croce. Then the urban sewer system, so the public sewer system carrying, in this case, since Florence is an old city, it carry combined water, so black water and rainwater. Considering also the surface runoff processes. So as you can see the animation of the hydrodynamic simulation we used this software in order to simultaneously calculate the water level and the surcharge condition into the drainage network, while the bidimensional engine was simulating the flood propagation over the surface. And here, the scale of the analysis was really a micro scale. And here we were able to evaluate the flow propagation into the building. The results of this kind of hydrodynamic analysis have been essential to define all the critical points of the network, recognize the most vulnerable areas and spaces, and investigate the dynamics of a potential inundation, or even, for example, reconstructing what happened during the catastrophic flood of the 1966. So, having all these results and this better understanding of the hydraulic behavior of the system, of the drainage system, and the topography itself, all this information allows the decision maker to propose, for example, sustainable, technical, suitable, more than sustainable, suitable, because we are speaking about a cultural heritage site, technical solution for safeguarding the heritage and all the important assets contained in this area. And for example, here, thanks to this kind of approach, we or the decision maker are able to analyze both non-structural or hard engineering solution to protect some areas, or also non-structural strategies, for example, for the management of the hydraulic risk led by this pluvial flood. So we saw a case study where the scale of the analysis was quite, let's say, the small scale. So we analyzed one district of one city. But if we want to have a look at what happened at the administration level, we can say that authorities, water managers, urban planners, and also engineering offices are usually interested in understanding the hydrological, hydraulic behavior of their entire territory, because they are managing an entire area. And also they are really interested in knowing which is the impact of any modification, not just, for example, taking a new building. They don't want just to know which is the level of risk or the exposure of that new building, but they want also to know how this new modification will impact the entire system or the entire territory. So the challenge here is that, and we can summarize with this question. How to upscale a comprehensive analysis, so in this case, a comprehensive flood analysis without sacrifice quality and precision. Because usually when in hydraulics and hydraulic modeling, when we are analyzing a small scale, we can, let's say, introduce a lot of details. But then when we want to study the problem at the largest scale, we start introducing a lot of hypotheses, simplification. So, but what if we want to collect and maintain a high level of precision in our model? And Rat, I will say that we can start with the first pool now, before moving to the second part. And here we want to ask you, which kind of approach, numerical approach, do you use for this kind of pluvial flood analysis in urban areas? Because as we know, the urban environment is really, really complex. It contains a lot of features. I guess I can go ahead, right? Or I wait for the
Sure. Yeah. No, you can keep going. Yep.
Okay, perfect. So we saw the first study case at the city center of Florence and the cultural heritage site of Santa Croce. And here we present another studies